Hi, glad you're back. Tell you what, today we're going to see something very interesting, which is how to set up the components of our agent. So here we have our routing system agent that we placed into the decision network, and we saw last time that by double clicking on it, we can open, let me drag it here, the event graph editor, where we can set up the events that are going to trigger the actions on our agent. So we can use the event graph to set up the components of the agent. And here we saw last time we have the fleet component, the fleet of vehicles, the location component describing the location that we want to visit, and finally the route component, which is the route that we want to optimize. So we saw also that we have some events, and in this case, for example, we can use the pre-simulation event to set up these components here. Why we want to use the pre-simulation? Well, for example, while we are simulating, we want to set up these components to prepare them for simulation, and then the actual simulation is going to optimize these components, is going to create the routes, and then on post-simulation we can visualize these routes. In production, once you simulate and you're happy, you're going to deploy the system, and you're going to leave all the graph exactly the same, but you're going to replace probably the pre-simulation event with an API call, for example, right? If you want to trigger the setup of the components or the actual agent optimization with some API calls, right? So you're going to replace these events here, the triggering events, with some API calls event. So let's go ahead and let's say that, for example, we want to set up the fleet. If we click on the fleet, we're going to see here the fleet component is an environment component. We talked about environment component last time. That can be specified as a struct object in this format here. And you see we have a name, start location, and the driver, the name of the driver. All right, so to set this component, we can just drag it and drop in the window. And then you see that here we have some functions. We have also a set of utilities and functions for each component of our agents, right? So fleet, location, and route. And if you see it under fleet, we can set fleet name, start location, drivers, semantics. So you can basically specify each single element of our fleet component, or you can using set fleet semantics set the entire fleet at once. Why? Well, let's go ahead before saying why. Let's set we want to set up the fleet name here, right? We want to set up the name of the fleet, so we wire up these things. We need to specify a target, which is our fleet component, like that. And then let's create a variable like a fleet name, right? We want to set the name, something like so, drag and drop. And then here you see we want a string value, so we're gonna connect these things, and then say that this is a string and my fleet here. Then we want probably also to visualize this at the end, so we can put down a post-simulation event, and then we want to say let's do a print string. The print string, if you remember last video, is going to print when it is triggered something, a log message on our main window here in the details panel. So let's go ahead and set this up by wiring these two blocks. Let me drag here. Let's put this in front here. And then the string value, well, we can print the string. We cannot connect directly the fleet component to the string value because fleet is an object, the component actually is an object, and the string value is a string. So to do that, we can use other functions. For example, we can use a serialized component. So we connect the serialized component, and then again we cannot connect directly the serialized component method to the print string because this is going to, as you read, if you click on it, it's going to return a dictionary, right? So it's taking the object and it's encoding, serializing the object as a dictionary. So we cannot connect to a string, but what we can do is to connect now to use a two-string block, something like so, and this actually returns a string value that we connect here. Also notice that we cannot connect directly the fleet component to the toString because that would take the actual object and convert it to a string, and that would probably be the ID of the object, right? Like in Python, for example, if you're familiar with Python. Very good. One thing I want to mention is that you see that here you have green blocks and blue blocks. What are these things? Well, we are talking about pure functions, which are the green ones, and non-pure functions, which are the blue ones. The distinction is that pure functions are not modifying any object, and neither the environment or our GUI. So are only getter functions or, for example, operators or converters, right? Converters. So, for example, the toString converts one element, one type to another, right? To a string type, and doesn't modify anything else. The non-pure functions, the blue blocks, are instead modifying something. The set fleet name is going to modify the name of the fleet, right? So it's going to modify the object itself. The print string seems weird. What does it modify? It just prints. Well, it modifies our interface, our GUI. So it's affecting what we see somehow. And the other main difference is that you see the non-pure functions, they have some wires, right? They are triggered by actions. Here, basically, they receive an input and they convert the input, or they do something to the input and they return a result, right? They are not triggered by anything else. They are just queried, right? This print string is going to query this block, which in turn is going to query this block, and so on, and then returning the result back. So now, when we simulate this, we can see what is going to print by running this, and we see that we run the simulation, and the name of that object is my fleet. Very good. So now we basically change this, and we printed the string here. There are other ways to change this component, and I'm going to show you what we can do. So one way is to set up each single parameter, right, of our fleet. So fleet, we can change the fleet name, the start location. In that case, we're going to use a variable with two float values, right, the coordinates. We can add a driver, but sometimes this is a very long process, and you want to set the fleet as a whole, right? You want to set all the different elements of the component at once. You may want instead to set each single element of the component if, for example, when you deploy, you want to change something, only something. So, for example, you want to add a new driver, right, at your system that is already deployed. But in that case, you can just use an add fleet driver block and trigger that by an API call. So you call the API that is going to add a new driver and then re-optimize the system with a new driver without changing anything else. But if you want instead to set everything at once, you can use the set Fit Semantics here. So this is a block that you can trigger like this, and then when you double click on it, you're going to open an interface here, a window, and you see that now you can set everything in at once, right? So my name, I can change the name. I can say that now this is my other fleet, right? We can set some latitude, longitude, I don't know, 1, 2, 3, something like that, and we can add some drivers, right? Mario and Luigi, something like so. Now you can set up everything in one single place, as we said. We can do the same for the location, and here you see that we go to location. We can set the location group name. You can add locations, and you can add everything at once by using the set location semantics. So let's see first what the location component is. Again, we click on it, and we see that the location component can be specified with a name and then a set of locations that you want to visit, the coordinates, right? So to do that, we can basically do this. We can add location, and then we say set location semantics to specify all at once. We connect these blocks here, target is location component, and now when you double click on the location semantics, again, semantics means that you set everything at once. You double click on this, you're going to open up a window where you can see basically a map of the centers at the location that you want. In this case, Boston, the location group name, and then you can click, right click, you can pick some locations here you want to visit, right? Very good. So let's see. Okay, this is done. So let's try to simulate. Undefined error on simulation, and we have set Fit Semantic input not connected, and that is why because we didn't connect a target. So you see, this is my bad. Set Fit Semantics. Yeah, we should have connected this block with this. And now you see that the name is my other fleet, and then start locations, name Mario and Luigi, as we said before. Very good. The last thing I want to show you is that if you don't want to use, let's say you don't want to use the user interface while you deploy a system, you don't want to use, of course, the user interface, you want to do everything, set up all the components with an API call, well, you can do that by instead of going to the single fleet and location and picking up the semantics, you can use a function which is set component semantics, and this is set semantics in general. So the set component semantics wants a target as we did here, remember to put it up, otherwise you see an error as we just seen, and it wants a struct value. So how do we do that? Well, let's try to show how to do that. Well, we can create a new variable. Okay, we cannot pick the same name. Fleet name, so it's struct, right? Struct var. Very good. We can drag and drop the variable here, and then we can connect this. Right, struct value. Here now you see that we can choose among the different types here a struct. Right, when we choose a struct, we can print the struct as a JSON. Basically, you can define the structure as a JSON, and if you see here, I created basically already a location, fleet and location. I can give you all this input data here if you want to try yourself when you download the interface. And you see that here, for example, we have the struct describing the fleet JSON, and you see that we have a name, Boston Fleet, we have the start location, we have the drivers, Mario, Luigi, and Peach. So we can just simply copy this, okay? We can use it into here, right? And you see that now we have our struct here. So when it's going to be triggered, this is going to use the setup, basically the location all at once by reading the struct value. And you can use this, for example, to change your locations or to change your fleet once the system is deployed, right? So you are going to, once it is deployed, you're going to change this to an API event. An API is going to receive, with your specified endpoint, is going to receive some data. The data is going to be JSON, for example, and the JSON is going to go inside the value here. And at that point, you're going to change, basically with an API call, your input, and then rerun the optimization agent. And the similar thing applies for the route. Now, there's nothing to set here. If you see the route component, this is basically the description of the route, right? So your route, you have the actual route, the list of the places that you're going to visit, the total distance, and who is going to visit that location, right? We are going to use the post simulation event with the route component. So basically, what we are going to do is going to use the pre-simulation to set up fleet and location, and then post simulation. So pre-simulation for fleet and location, and post-simulation for printing the route. And during simulation, we're going to run our decision maker. Decision maker is another agent that takes ownership of our routing system and decides how the routing system should behave. But this is all the time I have for this video. I hope you enjoyed, and next time we are going to see something even more exciting, which is how do we model the behavior of an agent. And there are some AI techniques that are very, very powerful that you can basically combine blocks together to define very complex behaviors by simply linking together sub-behaviors. And we're going to see this and how to do that with the decision maker in the next video. I hope you enjoyed this video, and if you're excited, just go into the link below and go to parallel.ai and ask to try out our interface. Thank you for watching, and I'll see you next time.